Okay, in this section, we're going to be using our properties that we learned last time about how to condense and expand our logarithms, except that there's going to be parameters, and so we're going to have to use the parameters that are given in the directions. So for example, on this first one, it says write each logarithm in terms of natural log 2 and natural log 3. Well, if I look at part A, it says natural log of 6. That's not in terms of 2 and 3, but I do recognize that 6 has a factor pair of 2 and 3. So if I rewrite that as natural log of 2 times 3, now I can use my expanding rules of logarithms to say natural log of 2 plus natural log of 3, and I'm done. I've satisfied the parameters of writing each logarithm in terms of natural log 2 and natural log 3. So part B starts out with a natural log of the quantity 2 divided by 27. Well, since the original problem is a division, I know that I can write natural log of 2 subtract natural log of 27. Okay, natural log of 2 is okay because that's within my parameters, but natural log of 27 is not. But I recognize, though, that 27 is the same thing as 3 to the third power. 3 times 3 is 9 times 3 is 27. So if I'm going to write that, then I could say natural log of 2 minus natural log of 3 to the third. And then remember our power rule. We can bring this power out in front. So my final answer is going to look like the natural log of 2 subtract 3 natural log of 3. So everything is in terms of natural log 2 and natural log 3. Let me point out that this power right here doesn't have to be a 2 and a 3 because our parameters are natural log 2 and natural log 3. That's just coincidence that that's a 3. That number could have been 4, 5, whatever. When it says natural log of 2 and natural log of 3, they're talking about this piece right here, natural log of 2, and then that piece, natural log of 3. That's what needs to be in terms of the natural logarithm. So if you have a power, it can be whatever it needs to be. All right, so down below it says write each logarithm in terms of natural log of 2 and natural log of 5. So same thing once again. I recognize that the natural log of 10 is the same thing as 2 times 5. So if I expand that out, that's going to go the natural log of 2 plus the natural log of 5. And then over here on the right, the natural log of the quantity 5 divided by 32. Well, my first step would be to expand it out to natural log 5, subtract natural log of 32. And then once again, I recognize that 32 can be written as, this one is a base 2. I could do that as 2 to the 5th power. So I'm going to write that as natural log of 5 minus natural log of 2 to the 5th, and then I'm going to use my power rule and bring this 5 out in front, and so now I'm going to have the natural log of 5 subtract 5 natural log of 2. Okay, so more of the same idea. Our parameters are changing on this one. This time it says we can only do log 3 and log 5. So 75, first thing I was thinking of was 25 times 3. That was the first thing that popped into my head. So I could say log of 25 times 3. 25 is not within our parameters. 3 is, but 25 is not. But I do recognize that 25 could be written as 5 squared. So I could write this as the log of 5 squared times 3. Okay, now let's go ahead and expand that out. That would be log 5 squared plus log 3. And then once again, that power 2 can come out in front, and we have 2 log 5 plus log 3. Does that fit our parameters of only writing our answer in terms of log 3 and log 5? Yes, it does. Over here, log base 9, or log of 9 divided by 125, that could be written as log 9 minus the log of 125. Okay, neither one of those are within our parameters, but I recognize that 9 is the same thing as 3 squared, And 125 is the same thing as 5 to the third. And 3 and 5 are within our parameters. So that's going to be log 3 squared minus log 5 to the third. Then we're going to do our power rule and bring the power out in front. So 2 log base 3 minus 3 log base, or log 5, not base 5. So log 3, 2 log 3 minus 3 log 5. Those are base 10s. We don't see any bases written there, so they're understood to be base 10s. Okay, so that's how we do those. Okay, so now below, this time we've got log base 2 of 3 and log base 2 of 5. Same idea, we can only do in terms of 3 and 5, but our base is different. It's a 2 now, not a 10. So let's go ahead and see how that expands out. Okay, here we go. On this one, log base 2 of 5/3. So I'm just going to go ahead and write that as an expanded log base 2 of 5. Subtract log base 2 of 3. Does it satisfy our parameters? Yes, it does. That's log base 2 of 5 and log base 2 of 3. Okay, over here, 45. I recognize that 45 is 9 times 5, but 9 is not in the parameter of log base 3, but I do recognize that 9 is the same thing as 3 squared, so I'm going to use that. So I'm going to say log base 2 of 3 squared times 5. So we're going to expand that out. So log base 2 of 3 squared plus log base 2 of 5. And then use our power rule and bring the 2 out in front. So log base 2 of 3 plus log base 2 of 5. And now that satisfies our parameters. Okay, so same thing here. This one says we can't use a calculator, so we can only use what's given in the parameters, and it looks like it's a log 7, a log 8, and a log 12 for part A. So it looks like to me I have 1 over 1 divided by 49. Okay, the other, even though 7, 8, and 12 are in our parameters, the other one that I know that I can use is log 1. Even though it's not in our parameter, I know I can use it because log 1 is always equal to 0. Anything raised to 0 power is always 1. So I can use that, and I can also use 10. These are all written in base 10. So I can also do log 10 of 10, which would also be 1. So basically the numbers that I'm confined to use now in my parameters are a 7, an 8, a 12, a 1, and a 10. I can use any of those numbers to rewrite and to figure out to evaluate. So I'm looking at log of 1 divided by 49. So right off, I think I'm going to write that as log 1 subtract the log of 49. And then I recognize 49 is the same thing as 7 squared, and 7 is a number that I can use. So I'm going to say log 1 minus log 7 squared. Use my power rule. So log 1 minus 2 times log 7. Okay, once you get it all expanded out, now we'll go ahead and use the values that they gave us in the directions. So log 1 I know is 0. I've already written that one up there. So this is 0 minus 2 times what is log 7? In the directions, it's 0.8. So a negative 2.8 would be a negative 1.6. So my answer is a negative 1.6. Okay, so on this one, we're supposed to figure out log of 84 without our calculator. So once again, our parameters are we can use the number 12, 8, 7, and once again, we can still use 1 because 1's always allowed to use because we know that's always equal to 0. And since this base right here is a 10, we're also allowed to use a base 10 because we know that will also equal 1. So the numbers that we're going to be allowed to use are 12, 8, 7, 1, and 10. Okay, now when I'm thinking about 84 and I'm trying to think of all the factors, first thing I think of, well, it divides by 4. So I'm just going to go ahead and write out what its prime factorization would, well, close to its prime factorization. I'm going to go 4 times 84. So 84 divided by 4 is going to be 21. But then I notice 21 is going to be the same thing as 3 times 7. So, oh, okay, well, 4 wasn't a number in our list, but look, 4 times 3 is, so we can use log of 12 times 7. And maybe some of you saw that right off. 12 times 7 is 84. I didn't, but I got to that by starting a prime factorization so I could see what all the factors are. So we'll go ahead and expand that out. And so this is going to be log 12 plus log 7. And then log 12 is going to be 1.1. And log 7 is 0.8. So we're going to add 1.1 and 0.8, and we're going to get 1.9. So that's equal to 1.9. Okay, we'll try it again. This time, instead of numbers, though, they're going to give us variables. Oh, let me backtrack. Sometimes, not on either one of these two, but sometimes you might have to take and multiply. Let me think of an example here so that you can see what I'm talking about. Just a minute. Let me think of an example. Okay, so I'm making up this log of 168, which is basically the problem we just did over here. It's the log of 84 times 2, so it's 84 times 2. So if you were to expand that out, you could say it's 2 times 12 times 7. But the problem is log base 2, this right here, so we could go log 2 plus log 12 plus log 7. But the 2 is not a number that we're allowed to use. So what you could do in this scenario is up here at the beginning, you can multiply by 1, meaning you can multiply the top and the bottom by 1. And, oh, this is not a good example because it won't turn out to be a number. Let's see. Let's say we multiply by, what I was thinking was if I multiplied the top and the bottom by 4, then you've created an 8 in the top, but now you have a 4 in the bottom, and that's not a number we're allowed to use either. Okay, so just a minute. Let me think of a better example. Here, let me turn this off for a minute, and let me get you a better example, because there is one like this in the homework, so I just kind of want to highlight this. Okay, I found one that will highlight the property that I was trying to talk about that's going to be in the homework. So given were these 3 logarithms, but we also know that we can use log base 3 of 3 because that's a 1, and we can always use log base 3 of 1 because that's a 0. So the numbers that we're going to try to use are 8, 11, 10, 3, and a 1. So if you look at log base 3 of 15 divided by 4, it's pretty easy to see that 15 is the same thing as 5 times 3, and that's pretty much it. That's its only factor pair. And 4 is 2 times 2, or 4 times 1. But 4 isn't in our number set, so 2 times 2, and 2 times 2 isn't in our number set. So we need to figure out what we can create here by multiplying by some other number. So what if we did, because we have an 8, 11, a 10, and a 2 and a 2, that's not going to work. So what we're going to want to do is we're going to want to multiply. So we can multiply by 1. So a disguised 1, I'm going to choose 2. So I'm going to do 2 over 2, and I'm going to change my problem. It doesn't change my value because this is log base 3 of 30 over 8. But if you took the fraction 30 over 8 and reduced it, you would get 15 over 4. So I haven't changed the value. But I have created something that I can now use my numbers 8, 11, 10, 3, and 1. Because 30 is the same thing as 3 times 10. And both of those numbers are numbers we can use. And 8, of course, is already on our list. So when we go ahead and expand that out, we're going to write that as log base 3 of 3 plus log base 3 of 10 minus log base 3 of 8. And now we'll go ahead and put in the values. 3 of 3 we know is 1. Log base 3 of 10 is 2.2, so plus, or 2.1, sorry, 2.1. And then we're going to subtract log base 3 of 8, which is 1.9. So we'll go ahead and figure out what that answer is, and that turns out to be, so that's 1.2. So when you're doing this, another property that you can use is to multiply both the top and the bottom by a fraction, by 1. And it's a disguised one, and you're just going to have to figure out what number you can multiply top and bottom by to create new numbers that can be used with what the given parameters are. So not only can you use the same base number and 1, but now you have the idea that you might have to multiply to figure out how to expand that. Okay, back to this one now. This one says use properties of logarithms and rewrite in terms of the variable given. Okay, so this is kind of like what we were just doing. We have to expand it all out, but we have to use variables in the end instead of numbers. So we can't put the variables in at the beginning. We have to wait until the end. So we need to expand this out. So we're going to have to go ahead and take 500 divided by 3, and we're going to have to expand that out. So we're going to have to worry about 500. 3 is not on our list. So right off, I feel like, ooh, maybe this is going to be like what we were talking about here just a minute ago. We might have to multiply by something. If I multiplied both top and bottom by a 2, like we did on the last problem, you would end up with log base 4 of 1,000 over 6. And 6 is good because 6 is one of the numbers we can use. We can use a 7, a 10, and we can do log base 4 of 4. So we can use a 4. And we can also do log base 4 of 1 because that'll give us 0. So we can always do 1 and whatever the base is plus the given parameters. Okay, so 1,000, I can do 1,000 because 10 is one of the numbers, and 1,000 would be 10 to the third. So I'm going to rewrite this as log base 4 of 10 to the third divided by 6. Now I'm going to expand that out. Log base 4 of 10 to the third minus log base 4 of 6. Keep expanding. And I'm going to have 3 times the log base 4 of 10 minus log base 4 of 6. So 3 log base 4 of 10. So log base 4 of 10 is z. So that's 3z minus, and log base 4 of 6 is x. So 3z minus x is the answer. Okay, so same thing over here on the right. The tendency is everybody wants to put the numbers in first. You cannot put the values in until you've expanded it all the way out. So this one, we really don't have to think about too much. We just need to expand it out and see what happens. So log base a of c squared, so log base a of c squared plus log base a of the square root of d minus log base a of b to the fifth. Okay, now let's go figure out all of our powers because we're going to use our power rule now. So that's going to be 2 times log base a of c plus 1/2. Remember, the square root's the same thing as the half power. Log base a of d minus 5 times log base a of b. Okay, now let's put in our values. Log base a of c is 2. So we're going to say 2 times 2. We're just substituting for this piece right here. Plus 1/2, and let's substitute for log base a of d, which is -3. Minus 5 times, now let's substitute log base a of b. That's -1. Okay, so 4, and then 1/2 times a -3 is a -1.5, and a -5 times a -1 is a +5. So you've got 9 minus 1.5. So that's going to be 7.5. So your answer is 7.5. Okay, so same thing again. We'll try each one again, and then then you've got a worksheet to do. So this one right here, log base 8 of 4 divided by 5. I noticed that 4 and 5, neither one of those are in my problem. If I did, once again, multiplied by 2, I would now create, and it's not always by 2, guys. It's coincidence that that's probably what I'm picking. It's probably the easier types of problems to create, but it's not always multiply top and bottom by 2. But, it's a good place to start, I guess. So that would be 8 over 10, and 8 is a number I can use because 8 is the base. So I'm going to go ahead and expand that out. Log base 8 of 8 minus log base 8 of 10. Well, log base 8 of 8 is 1 minus log base 8 of 10, which is t. So my answer is 1 minus t. Okay, and then our last one, log base 6 of 1 over 81. So 81 is 9 times 9, and 9 is one of our numbers there. So I'm going to go log base 6 of 1 minus log base 6 of, let me rewrite that, log base 6 of 9 squared. I'm going to bring that power out in front. So log base 6 of 1 minus 2 times log base 6 of 9. And so log base 6 of 1 is 0 minus 2 times log base 6 of 9, which is r. So our answer is a negative 2r. Okay, so that's what you're going to be doing in the homework. You can go back and rewatch any of the examples you need to help you figure out how to do those if you can't figure them out. And then we'll be moving on to 3.4 next time.